So this lecture is on the traveling salesman problem, or traveling salesperson problem. Now, the goal for the traveling salesperson's algorithm is that you start from a city and you have all these other cities you have to visit and do sales in there. So the goal is to visit every city and come back to the same. So you start at this vertex, at this city, you visit A, B, C, and then you end up with A. So what I did was, I have a table with the cost associated, and I have this little code here that says, you got the starting, and then you can take the minimum distance of those two. Now if you look back here, if I start with A is my source, I can go to B, alright? I can go to C, and I can go to D. So these are my three choices. So it's A, B, so let me clear this one here. So this is, okay, so that's B. And then this one is C, so let me clarify this one. So this is actually C, okay. So as you can see, from A to B, A to C, A to D. I'm in B, I can go from B to C and B to D. From C I can go to C to B and C to D. D can go to D, D to B and D to C. Now from C I can go to D, so that's a D here. Now the reason I'm doing this here, because look, you go A, B, C, D. Then you go back to the vertex. Now, so D can go to C. So A, B, D, and C. A, C, B, D. A, C, D, B. A, D, B, C, and A, D. So everything is counted for. Now, these are like, I've traveled all this city. I need to go back to the vertex, to the source, to where I came from. So I'm going to look my table. The distance from D to A, going back to A from D going back to A is 8. That's why I wrote 8 here. Now, from C to A, the distance is 6, or the cost is 6. From D to A, it's actually 8. So I'm going to leave the 8 there. B to A is actually 5. So this is B to A, that's a 5. C to A is actually 6. This is 6. B to A is 5. So this is going from D and then going back to the original vertex. Okay. Now, what is the distance from C to D? Now, the distance from C to D is actually 12 plus 8. So that gives me 20. Because I have to go C to D and D to A. The distance from, or the cost, whatever you want to associate that with, from D to C is 9. 9 plus 6 is 15. So that means 9 plus 6, so 15. How about B to D? B to D is actually 10 plus 8, so that gives me 18. How about D to B? D to B, it's 8 plus 5, so that's 13. How about B to C? B to C is 9 plus 6, so that's 15. How about C to B? C to B is 13 plus 5, so that's 18. See, then we backtrack, so you're going back one level up. Now I'm going to go to B. Now there are two choices for B. I can go B to C. What's the distance from B to C? B to C, it's 9. So this will give me 9 plus 20. So this is actually 29. Now, how about B to D? B to D is 10. So I got 10 plus 15. This gives me 25. See, now I have 29 and 25. So I'm going to pick 25. Because that's the shorter way, or the cheaper, or the least cost. Now, how about C to B? C to B is actually 13. C to B is 13 plus 18. So C to B, which is 13 plus 18. So this is now 31. Okay. How about C to D? C to D is 12. So I have 12 plus 13. So this gives me 25. So 25 is better for me. So 25 is cheaper. So I pick 25 over 31. Go back here. How about D to B? D to B is 8. So I get 8 here. I get 8 plus 15, right? So this gives me 23. Okay, so that's 23. Now D to C. I got D to C, which is 9. D to C is 9 plus 18. D to C is 9 plus 18. So this would be 27. So my cheaper one is 23. So I'm going to pick 23. 23. See that? Now, all I have to worry about is now I'm backtracking, and this is where I started from. What's the distance from A to B? Well, A to B is 10. 10. That's it, 10. A to B. That's 10. Now, I'm going to take the shorter one, or the least cost. So that's 25. So that gives me 35. Okay? How about if I take this route? A to C. A to C is 15. So this is 15 plus 25. So this is 40. Okay, that's the second route. Third route would be A to D. Well, A to D is 20. 20 plus the least cost here was 23. So this is 43. So as you can see, 35 is the least cost, so 35. So this is my least cost, which is 35. Now if I look back at this, so to see the minimum path, so I'm going to go from A to B to D to C back to A. So it's this way, A to B, okay, B to D, D to C, and then back to A. See that? So this is what I mean by the minimum. So this is my minimum path algorithm. So see that? I go this way and that's back to A. So this is how I end up with 35. And that's it. So this is known as the traveling salesperson's algorithm, or traveling, whatever it's known as. And so this is A to B, B to D, D to C, and C to A, and that should give me 35 units, and this would be the cost. So thank you for listening, and this is the traveling salesman problem. Thank you.